Okay, today we're learning something brand new with 13-3, part 1. This section, 13-3, is a lot and it's pretty complex, and so there's 2 parts to 13-3. Posting this one today, part 2 tomorrow. So we're talking about area of regular polygons, and if you guys recall, to be a regular polygon means that it has all equal angles and all equal sides. So that's what it means to be regular. Remember, a polygon is just a many-sided figure, right? So triangles, squares, pentagons, hexagons, heptagons, nonagons, octagons, decagons, so on and so forth. You can look back at polygons in chapter 6, okay? So that's where we get this formula as well. Regular polygons have all equal angles and side lengths. Each interior angle uses this formula. So remember, if we wanted to find what one interior angle of a pentagon is, we would do 5 minus 2 times 180 divided by 5, okay? And that would give us the total, each measure of each one angle, interior angle of that polygon, right? So that's from topic 6, okay, and that will come in handy, especially when we get to our example problems. Remember, if you follow the link to Pearson online, you can find detailed examples of how to get these example problems, okay? And so those are there for you. There are multiple ways to go about solving it. They use actually the exterior angle, or not exterior angle, they use that this would be 360 because we could put a circle around it. But also in this sense, just to show you a different way than how the book does it, using our formula for our pentagon, we could do 5 minus 2 times 180, right? To find what each angle is, and divide by 5. So 3 times 180 and then divided by 5. So we'd get 540 divided by 5, so it'd be 108. So each angle would be 108 in here, right? And so to find angle 3 in this circumstance, okay, and you can look in more detail about this later, to get angle 3 in this circumstance, we could just divide that angle in half, okay? So we could do 108 divided by 2. So we'd have 54, and that would be what angle 3 is, which is also what they got. They did it a different way. I just wanted to show you a different way than the book did, okay? And then we have a triangle. We know triangles equal 180, so we could find angle 2, double it, and we could find angle 1. So, like I said, just a different way of solving that problem. But let's go back to the notes, because we still have more to learn. Like I said, this section has a lot to it, okay? So we're learning a brand new word. It's called apothegm. I know it sounds like a possum, but it's apothegm, okay? Apothegm. It's the perpendicular, remember perpendicular forms a right angle, distance from the center of a polygon to a side. And I always want you guys to look for the right angle, okay? Because if we have our apothegm here, it goes from the center of the polygon to a side, and it's perpendicular, so it forms a right angle. So we're always looking for that right angle right here. I don't want this line just going anywhere. I want it going to the perpendicular to one of the sides, okay? And if it's a regular polygon, what it's actually going to do is split this side in half, but we'll get to that tomorrow as well in 13-3 part 2. So now for the actual area of a regular polygon, and you can see this in the poster that's posted on Instagram. And if you've been paying attention all year, it's the one that's right above my board, right above the bell ringer, is this area formula. So it's half the apothegm times perimeter. So we take the apothegm length, and for today's problems, you'll be given the apothegm. Super simple, times the perimeter. Okay, and if you guys recall, perimeter is the distance all the way around the shape. So if like this side is 6, well, since it's a regular polygon, we know all the sides are 6. So we do 6 plus 6 plus 6 plus 6 plus 6 plus 6, or 6 times 6, 36 times whatever our apothem is, okay? So that's how you would find the area. And then don't forget to divide by 2. Don't just multiply these two numbers without dividing by 2. Remember the formula, okay? And then the last part is just what I was saying, a little refresher. Perimeter is distance around the shape. On a regular polygon, it will only give you one side. So like I said, if I know that this side is 6, all I have to do is take the length of one side times the number of sides, okay? And so with that, you guys should be able to do 1 through 7. They're actually pretty straightforward. Example problem 2 walks you through this type of problem. Like I said, on Pearson Realize, that's where you can find detailed explanations of this. But on those practice problems, we'll get to this tomorrow. On those practice problems, you're going to be using what we did in example 1 on the first 3, and just using the formula 1/2 apothem times perimeter. And if you don't remember what these side lengths are, you could look at the poster from topic 6, or you could Google them. That's fine as well, to find out how many sides these have to figure out the perimeter, okay? This is just one side, not the whole perimeter. So in our formula, don't forget, you need 1/2 apothem times perimeter. So make sure you find the perimeter first, okay? So that's 1 through 7. They are really simple and doable. If you guys want to try those out, I highly recommend it.